Hello everyone, this is Mayank and welcome to a new system design video. In this video, we are going to talk about one of the most fundamental topics of system design, that is scalability. So without further ado, let's get started. In this video, we are going to understand what is scalability, the two different types of scalability. You have horizontal scaling and then you have vertical scaling. Once you have understood both the concepts, then we'll go over the comparison between these two scalings. So basically we'll go over the pros and cons for each type of scaling. So those are the 4 things that we are going to cover in this topic. So stay tuned and keep watching. In order to understand the concept better, let's take a simple example. So let's assume that you have a service which converts a given text to speech. So as a user consuming your service, the user is going to send a request in the form of a text, and the service is going to respond with a response consisting of the audio file. So you give a text and you get a response in the form of an audio file. That's your service running and it's hosted on a server. Assume that you just launched the service and then you're getting on a daily basis some requests per second. So that's your traffic. Now, the ability for the system to manage load as and when your service becomes popular can be defined as scalability. So as and when you're getting more and more requests, the ability for the system to handle that particular load, how does your system respond to those incoming requests or incoming traffic as and when that traffic increases? That's basically scalability. Now, let's jump into the details of what a horizontal and a vertical scaling is. So let's assume that you start with a single server and then for the first month, you're getting a traffic of 10K requests per second. So that's your traffic, that's your initial traffic for the first month. And with this particular load that you're getting for the first month, with a single server, you are able to manage your load. For the second month, your service gains more traction and becomes a little more popular. That's when you start getting 100K requests per second. And when you see this particular traffic come in, you also see a lot of users complaining about slow response from your server. So whenever they're requesting for a speech for a specific text file, there is delay in response. Requests are getting timed out, which essentially is leading to a degraded user experience. Now, in order to solve this particular problem, what you do is you employ a bigger machine. So initially, let's say your server had a capacity X. What you have done is you have replaced that particular server with a bigger machine. So whatever your capacity was, you have just doubled it, and that's your new server's capacity. And you have hosted the same service on this new infrastructure. So you have the users now still able to access that service, but on a bigger machine. So you're getting the requests and your response is in the form of an audio file with a server operating at 2x the initial capacity. With this particular new infrastructure in place, it's able to handle the 100K requests per second load completely fine. So there is no delays, no timeouts, and your users are happy again. But let's say in the subsequent month, your service gains more popularity, and that's where you're getting more and more requests to your service. So let's say you are getting 1000K requests per second. The moment you start getting 1000K requests per second, your server again starts to cry. So you no longer are able to serve your users with the same latency which you were doing when you were getting 100K requests per second. And that's due to the fact that your server is just not able to handle the new increased load rather, which is 1000K requests per second. Now, in order to solve this problem, you think of getting a bigger machine. So you start procuring an instance or a server which is 4x the initial capacity. So now it's just doubling the capacity that you were operating on when you were able to handle 100K requests per second. So this approach of you increasing the capacity of a single server is known as vertical scaling. So what you're doing is you're replacing an instance with a bigger machine. Every single time you think that, okay, your server has reached its maximum capacity and it no longer can serve any additional request coming in. So this particular concept is known as vertical scaling. There are a few challenges with this particular approach. Always there is going to be finite capacity when it comes to a single server or single instance. There is always going to be finite capacity and it cannot go beyond a certain limit. So there is always going to be hardware limits when it comes to vertical scaling. Another drawback or disadvantage that you can think of here is every time you try to upgrade your server, there is going to be downtime. So you are always going to incur some downtime where your service is not going to be available to the audience, to the users for the time duration where you are doing the upgrade. So let's say this takes T1, this takes T1 time. So this particular time instance, it could be 5 minutes, it could be 10 minutes, whatever the time duration is for you to upgrade the server. It's just going to be unavailable. So your service is going to be unavailable. So that's again a bad user experience. But that's all about the vertical scaling. There is another approach in order to solve this particular problem. Let's talk about that. So let's assume the same server, single server having X capacity, running a text-to-speech service. So you have a user, he's sending the request, getting a response, and you're getting, let's say, 10K requests per second. As and when your service gains popularity, as it did in the second month, you start getting 100K requests per second. And you now know that this particular single instance is no longer sufficient to handle this particular load. Now, in order to cater to this new additional traffic, instead of getting a bigger machine, you think of procuring another machine with the same capacity. So you have one instance running at capacity X, you get another instance with capacity X. So now you have two servers, S1 and S2, both running the same text-to-speech service. And now with this new cluster of, with this new additional server, your users are happy and they are able to get the response in the stipulated amount of time. So there is no additional latency incurred when there are requests coming in, or there is no timeouts that the users are observing. So this is another way for you to solve for scalability, wherein instead of buying a bigger machine, you just procured another machine with the same configuration or the same capacity, and it's able to handle the load. But basically what you have done here is you have distributed your load between two different servers. Let's say your service, as in the third month here, starts getting 100,000K requests per second. Now, in order to solve for this, what you could do is, instead of getting just additional one, you could get two more servers. So now you would have a cluster of servers where you would have S1, S2, S3, and S4, all running at X capacity, right? And what you would have is all the 1000K requests coming in now would be distributed between these four servers. So without having any need to buy a bigger machine, you are able to solve for scalability. You are able to scale your service well by just adding additional servers to the existing cluster of servers. If your number of requests or your traffic rather goes up, you can keep on adding more servers. So it's just a matter of you getting and procuring more servers with the same configuration. There's no need for you to go ahead and buy a bigger machine. This particular approach of you getting more and more servers or adding more and more servers to your existing cluster of servers where your service is running is known as horizontal scaling. So what we have learned so far is the fact that in terms of vertical scaling, what we were doing was we were always replacing the existing server with a bigger machine. We were trying to increase the capacity for that single instance on which our service was running. Now, in terms of horizontal scaling, instead of replacing that single instance with a bigger machine, a bigger capacity machine, we are adding more servers with same or similar kind of configuration. So that's the difference between a vertical scaling or vertical scale system and a horizontal scale system. Now that we have understood the concept of vertical scaling and horizontal scaling, let's try and compare both these kinds of scaling. So you've got horizontal scaling and then you have got vertical scaling. Now, in terms of horizontal scaling, what we have learned so far is we are adding instances. So we are scaling out our service. We are adding more and more servers to our existing cluster of servers. In terms of vertical scaling, it's always going to be a single instance, and that's the biggest computing engine that you can purchase. So that's your vertical scaling. So you're scaling up your service. Now, one of the things that we need to keep in mind is because you're operating or because you're working with multiple servers, there's always going to be a need to balance the traffic or to route the traffic to multiple servers. So you need some sort of a load balancer. For it to distribute the traffic that's coming from your users. Otherwise, you would end up having duplicate requests or the same request getting processed by multiple servers, or there could be one request that is not processed by even a single server. So you need some sort of a load balancer to ensure that one request gets served by one server and gets redirected to one server only. In terms of vertical scaling, because you're always working with a single instance, this doesn't apply. So you don't need a load balancer because you're just working with a single instance. The next difference is in terms of horizontal scaling, because you have multiple servers to work with, it's always going to be fault tolerant. Now, what I mean by fault tolerant is the fact that anytime a single server goes down, you have other 4 servers in this particular example for it to ensure that your service is up and running and to be able to manage the load. So it's always going to be fault tolerant, or I can say it's resilient. In terms of vertical scaling, because you're always working with a single instance, and if this goes down, you're basically working with a single point of failure. So at any given point in time, if this single instance goes down because of memory timeout, memory issues, or it's just power failure, this particular service is no longer going to be available. The next difference is with respect to the network calls. Because you're working with multiple servers, there are always going to be network calls or remote procedure calls that you would have to do in order to get data from a downstream service or from another service that's hosted on a different server. So there are always going to be latency constraints when it comes to vertical scaling. So you have network calls or you have RPCs which incur latency because these are going to happen over the wire, over the network. In terms of vertical scaling, because all your infrastructure or all your services rather are hosted on a single server, there is always going to be inter-process communication, which is going to be fast and low latency with respect to network calls. So here you are going to have inter-process communication, which implies low latency. Because there is no network call, there is no call happening over the HTTP protocol. The next difference here is going to be with respect to data consistency. Now, because you are working with multiple servers and your data is distributed amongst these servers and they might be talking to their own database, data consistency is always an issue. When it comes to vertical scaling, because you're always working with a single instance, data consistency is relatively easier to implement. The last bit of difference that we can observe here is as the number of users grow, as your service gains popularity and your customer base increases, it's easier to scale when it comes to horizontal scaling, because at the end of the day, what you're doing here is you're just adding more instances. Now, at any given point in time, if I wanted to add 2 more instances, it's not going to bring my service down. My service would be up and running all the time, and it would be relatively easier for me to keep on adding more instances to the existing cluster of servers. So this particular concept or this particular approach of horizontal scaling scales well as the customer base increases. In terms of vertical scaling though, as we discussed in the previous examples, that there is always going to be finite capacity in terms of the biggest machine that you can procure for a specific service that you're running and you want to deploy that on. So there's always going to be hardware limits or hardware challenges when it comes to vertical scaling. So yeah, that's about it guys for this video. So just recapping what we discussed in this one, we discussed what scalability is, we discussed the horizontal and vertical scaling, understood with an example of how both of the scaling approaches can be implemented, and then at the end of it, we discussed the horizontal and vertical scaling and then compared them. So yeah, thanks for watching.